logarithms. Properties of logarithms go hand in hand with our properties of exponentials, exponents. They're just backwards. You only need to write down the log rule right here. So I'm just going to show you though how they go hand in hand with our exponential rules. So when you multiply the same base, instead of having two separate bases, we can write it as one base. When you multiply, you add your exponents, correct? When you multiply, you add. Alright, so logarithms, properties of logarithms is the same idea, it just goes backwards. So if we have log to the base 2 of x plus log to the base 2 of y, we can write it as 1 log base 2, and then when you multiply, you add. But it's just backwards. When you add, you multiply. So you can put it into one logarithm, which is considered more simplified with a time sign. Add, you multiply. Everybody good? Alright, next thing is, if you have the same base, dividing the same base, to put it into one base, we subtract. Alright, and we always subtract the top from the bottom. So, that goes hand in hand with this property of logarithm. Log to the base 2 of x minus log to the base 2 of y. We can write it as 1 log to the base 2. When you divide, you subtract. It's just backwards, so when you subtract, you divide. 1 log base 2 is considered more simplified than two separate. Alright, so we have this last rule is kind of stretching it. It's the same idea, but it is stretching it a little bit. So if we have a base, raise a power to a power, then you multiply the powers, right? You multiply. So this rule is just a little bit, like a little off, because what it is if you multiply, it's an exponent. So this y multiplied in front is actually just an exponent on my, what's inside my logarithm. Now this would be considered more simplified because then we just have log base 2 and nothing is attached to it. Does that kind of make sense? So we're going to have to be able to go both ways. We're going to be switching back and forth. But understand, guys, really the reason we go this way to this way because it's more simplified. The only time we would go from here back this way is just for practice to be able to go this way better. Because really one logarithm is better than two separated ones. Yeah, okay. Let's just do a bunch of examples, and I guarantee it's going to be really pretty straightforward for everybody. Okay, so we have log to the base 2 of 6xy. Now don't be mistaken, 6 is not connected to x. Well, I guess it is, but it's connected by times signs. When you multiply, you add. So we can split this up. There's three different pieces. We have log to the base 2 of 6, because when you multiply, you add. We have plus log to the base 2 of x. Then we have a plus log to the base 2 of y, and we're done. Pretty straightforward. Yes, we did. Okay, let's do another one. Log to the base 3 of x to the 4th, and then there's a times y to the 6th, so we have our rules here. Log to the base 3, I'm going to show my work, of x to the 4th. When you times, you add, plus log to the base 3 of y to the 6th power. Now because we're expanding, the next step would be to take our exponents and have them multiplied in front instead. So I'd be pulling it down in front, pulling 6 down in front, and now they're no longer exponents. They're times in front. Everybody good? So we have like 3 rules and only 3 rules. Alright, now this one is one that people actually get kind of confused on because notice there's 2 things in the top of the fraction and 2 things in the denominator. So now look, when you multiply, you add. When you divide, you subtract. Now people get thrown off because technically this is a multiplication too. So we'll talk about it. Alright, now everybody understand what I actually have is c to the 1/3 power. Agreed? I want to write it as a power so that when I pull down my exponent, it's pretty straightforward. So I have ln of a, then I have a plus sign because when you times, you add, plus ln of b. Now we divide, so we have a subtract, minus ln of x. Now what people want to do is they'll say, and now it's plus, because that's a time sign. But that is incorrect. You've got to say any negatives are basically what says it's on the denominator. So we've got to subtract. This is on bottom, so we've got to subtract again. So minus ln of c to the 1/3 power. And then from there, we'll bring our 1/3 power in front. Now let me explain why that is. Why we would put negatives on both of those. Technically, if I so desired, could I go like this? ln of a plus ln of b. Could I factor out a -1 here? Then left would be ln of x plus 1/3 ln of c. Now look what that says. We are timesing this this together, and they're both on bottom. You guys see? The negative puts them both on bottom. So you're going to always see me just say, if it's positive, it's on top. If it's negative, it's on bottom. It's really easy to remember. So you'll see me always distribute it through the negative. Do you see how they're the same thing though? There's a negative and then parentheses. Okay, so what I want you to do is try this one by yourself. Expand the logarithm. Now you only have 3 rules. When you multiply, you add. When you divide, you subtract. Fix your powers. Did we say anything about you can split apart addition and subtraction signs? No. Okay, so check your answers. So the first step I did was rewrite everything inside with fractional exponents, and then you only have your 3 rules. When you multiply, you add, divide, you subtract, take your powers and put them in front. There was no rule that said we could split apart addition and subtraction, so make sure you don't do that. Everybody good? Check your answer. If you have questions on any of it, make sure you ask if so. Notice there's 2 subtraction signs because these are both on bottom, so just don't forget that if things are on bottom, there's got to be a subtraction sign in front. All good with that? Ready to try another one by yourself? This is as hard as it can get, and then it's really, after you've done this one, you've done the extent of it. So, log of the square root of xy cubed divided by z squared cube root of p. So the first thing I do is rewrite that square root as everything is raised to the 1/2 power, and then I do that first, and then I start bringing exponents in front. So, yes, this is a z squared, everyone. Good question.
I think that's 1.5. Oh yeah, so I think it is 10. You're right.
Sorry, I'm doing it.
Oh, you're doing. Oh, okay.
Later, you have to get 1/3 times 1/2.
1/6.
Checking your answers and making sure you ask me if you have any questions on this one. This one was a tricky one. So just a reminder, remember that we are distributing the negative. Technically it's negative and then in parentheses, right? And a plus sign. So anything on bottom always has to have a subtraction sign.
So like everything on the bottom is going to be...
Always will be subtract. Because once again, look, couldn't I factor out the negative and then it would be plus in here, which makes it multiplied under here, right? So I just always, every time, distribute the negative because it's easier for me to just say. So anytime I have subtract, it's on bottom. And that's a great question. Yep. Okay, so the whole reason we expand the logarithm is really to be able to go the other way, which is condensing. This is really the important thing because we're going to be condensing when we're solving logarithms in the next lesson. But this is the only lesson for today. So now what we're going to do is combine the logarithm. Now everybody, I'm going to give you a hint. When you're combining the logarithm, you should only have 1 log written ever. So I always just start out by going like this. All right, they're both log base 10. So I just write a big log, and then I just put in some parentheses. There should only ever be, when condensing a logarithm, 1 log written. So now we have 3 as an exponent, isn't it? And then also, this is raised to the 1/2 power. So then what do we have here? X cubed times... Yep, the square root of x plus 1. Now, when you condense a logarithm, you are going to want to put fractional exponents back as radicals, everybody.
Wait, say that one more time?
So this is raised to the 1/2. Instead of writing it as 1/2, when condensing a logarithm, we're going to want to write it in its radical form.
I thought you said the other way around.
Yeah, sorry. Yeah, I can't guarantee you'll get it right. So, technically it's not their equivalent, but just for good practice, do it. Okay, so with this one, the first thing I would do is say, okay, they're all ln's. So I would write a big ln, and I put in some big parentheses. Now I see addition and subtraction signs, so I know I'm going to have multiplication and division signs. So I write in my division. If you ever see a subtraction, you know there's a division. Okay, let's put everything that's positive on top. So this 3 is an exponent, so don't we have s cubed? Then it's another plus, so we times, right? Square root of t, then subtract means flip, so then we have a
T squared plus 1 to the 4th.
t squared plus 1 to the 4th, right? So the negative flips it. Remember, the negative flips it. It's not going to be negative a 4th, or else you would have had plus negative a 4th, and then it would have got flipped anyways. Does that make sense? The math worked out the same though? Okay. You would have had a times, not plus. You would have had a times t squared plus 1 to the negative a 4th, and then it would have flipped down, so we just do it all at once. Good question. Now look, do you see, now, once again, would it be okay to fourth that? No. Because of the plus sign. Okay, good. Alright, let's do another one. You guys try this one by yourself. Now how I personally do this one is I take the 2, and it's times to all that stuff, isn't it? I personally distribute it in first, but that's just me. Now, if I times 2 in, should it go in front or inside the parentheses? In front. It can't magically flow inside of a logarithm. Okay, good.
Does it matter what order the subtraction and addition come in?
Nope.
Okay.
Okay, I personally distributed the 2 through, and do you guys see why I rewrote it as such? Now, any of those fractions that simplify, I would. So the 2 over 4 became 1/2. Notice I've written that. Then I'm just going to go through and put, I see subtraction signs and addition signs, so I know there's a divide sign. So this is x squared, it's positive in front, so that's on top. X squared. Now right here's a subtraction sign, so this is on bottom, isn't it? So that's z to the 1/2 power. We write it as the square root of z. Moving on. Now this is positive, so it's going to be on top, and that's an exponent. The 5th root of y squared. Roots go on bottom, power goes on top. Remember the picture of the flower. Right, awesome. And then we have another subtraction sign, so that's back on bottom again. And we have a times, and then it's on bottom my p plus 1 to the 2nd power.
Oh, okay, that's simple.
Yeah, I agree. Awesome.
Easier.
Okay, another one by, wait. Okay, never mind. I'm going to hurry and throw in a wrench because we saw something on the homework that I had not thought about. And I am going to hurry and quickly insert page. Okay, this is actually a really good one. I love it, actually, but I just didn't even think about it. So if we have ln of, let's say, x, the cube root of x divided by x squared minus 2x minus 3. Okay, now just a reminder, if we're splitting this apart, like meaning we're writing this as expanding the logarithm, we only have rules. Multiply, you add, divide, you subtract, powers are exponents. So don't be mistaken. Can I split apart these? No, there was no splitting this apart by subtraction, right? Yeah. Divide, you subtract. So what I have right now is technically this, everybody. 1/3 ln of x, true? Minus ln of
What?
x squared minus 2x minus 3. We can't just split those up, right?
Because of the
It's just when you multiply, you split it apart with addition. When you divide, you subtract. There was nothing that said subtraction can be split apart by. Does that make sense? Yeah. It's just there's just no rule that can let us split it apart. So we're here. But now here's the catch. That would not be considered completely expanded in the book because technically we have this 1/3 ln of x, and now we have minus ln, and technically in here, if the quadratic factors, we can expand more. Now let's think about why. So if I factored that, what multiplies to be -3 and adds up to be -2, 1 times 3, negative. This factors to be x plus 1 and x minus 3. When you multiply, you add. So can't I split that apart one more time? So now we have 1/3 ln of x minus ln of x plus 1, and then don't I need another minus sign? Minus ln of x minus 3. Okay, so just watch. If you're expanding a logarithm and the quadratic factors, factor it, and then it expands one more time because now you have a multiplication sign. Okay. All right, good. We're actually going to be winding down to the end of the lesson. Last few, and they're quicker examples. So it says combine the logarithm, and then it wants us to simplify because notice there's no variables. So you guys could probably just watch at this point with this one. So let's put it into 1 log base 2. If you log the base 2, whatever goes on top, let's put it on top. So 2 times 1/2 divided by 8. So then I'd rewrite it. We have log the base 2 of 1/8. Now, we have not learned change of base formula yet. So from here, when we were simplifying logarithms, we had to write it as a base 2, or the same as this base, if possible. So this would be log the base 2 of 1/2 to the third power. But now I can't cancel those out quite yet, can I? So now I'd rewrite this as log to the base 2, and then isn't this flipped over a fraction? Good. So this is actually a base 2 to the -3rd. And then what happens with log base 2 of base 2? Cancel out, so -3 would be my final answer. Okay, awesome. Let's do another one like that. So it says, oh yeah, I wanted to give a warning first. This is always what we see happening when we get to a test. So if I have log the base a of x plus log the base a of y, people will then say, oh, okay, so if I have log the base a of x plus y, I can split it apart with addition. Which is not true, because isn't log the base a of x plus log the base a of y log the base a of x times y? So you can't go this way. And then same here, log the base a of x minus log the base a of y is not log the base a of x minus y. Therefore, you cannot just call this log the base a of x minus log the base a of y. This would have to be log the base a of x minus log the base a of y is division. Log the base a of x divided by y. So then, same here, guys. Log of 6 divided by 2 is 3, but that's not what I'm talking about. I'm just showing you a rule that gets broken. People think you can split it apart as log of 6 divided by log of 2. Not true. Isn't this technically, if I said expand log of 6 minus log of 2? Which is not the same as division. So if you have something like this, you can't put it back together either. Okay, awesome. Okay, it says use the laws of logarithms to evaluate these expressions. So we would first, because we're using laws of logarithms, take this exponent up, wouldn't we? So then I'd rewrite it. We have log the base 3 of 9 to the -1/2 power. Now from here, aren't we trying to get it to be base 3? So then this is log to the base 3, and 9 is?
3 squared.
So we have 3 squared raised to the -1/2, don't we? 3 squared raised to the -1/2. So now raise a power to a power, and you multiply. So then we have log to the base 3 of base 3 raised to the -1. 2 times -1/2 is -1. So now what's my final answer? -1, because these cancel out. All right, so same idea here, guys. Look, log base 3 of, we have 100, and then divided by, we have an 18, and then it's on bottom is also 50. Now you'd have to do this by hand because your calculator cannot convert things back to fractions for you. So looking at this, isn't 100 over 50 2 over 1? So you would go, okay. Yep, so this is 1, this is 2. So then 2 over 18 becomes 1/9, doesn't it? So then you say I have log the base 3 of 1 divided by 9. Which is log to the base 3 of 1 over 3 squared, which is log to the base 3 of 3 to the negative 2, which is negative 2. Okay, awesome. Now those ones we're all able to simplify like that because we were able to write them as the same base. If we were given a log base 3, we were able to write the inside as base 3. If you're not, then you're going to use the change of base formula. Now technically you can always use the change of base formula if your heart so desires. So it says the change of base formula allows us to write our logarithm as a common base of 10. This way we can just use our calculator to evaluate instead of having to rewrite them as the same base. So if you have log of any base of anything, you can rewrite it as such. So log the base a of x can be rewritten as base 10. Log the base 10 of x divided by log the base 10 of a. Now you have to remember which one goes on top. The base is always on bottom, so log of what's in parentheses is always on top, divided by log of the base part is on bottom. So now notice if I said to you evaluate this, you would not be able to write base 5 as base 8. Therefore, you would have to use change of base formula. So this is equivalent to log of 5 divided by log of 8. And that is really easy because now I can just type it into my calculator. And you get big decimal. Just make sure your calculator's all good here. I get the decimal 0.77397 60316.
And usually they'll state if they want the whole thing or...
Yeah, if they don't state, you write down the whole thing. If they do state, you can round. So looking here, what would be the change of base formula? Yep, log of 20 over log of 9. Okay, moving on. Last example. Okay, so story problems are going to be pretty straightforward. It's going to be pretty plug and chuggish. So it says, if a task is learned at a performance level of p sub 0, then after a time interval t, the performance level p satisfies this equation. Log of p is equal to log of p sub 0 minus c log of t plus 1. It says, where c is a constant that depends on the type of task and t is measured in months. Now it tells us in part A to solve for p. So let's look at this. The first thing I want to point out is on this side we just have log of p. There's not really anything we can do to simplify that. Log of p is equal to. Now over here, can I write this as 1 log? Yes, right? Now when you subtract, do you subtract? You divide. So we have 1 log, and then it looks like p sub 0 is on top, then divide, because subtract, and then on bottom we have a t plus 1 to the c power. Now because we're solving for p, the log is the same, isn't it? So isn't the true statement going to be what makes the inside the same? Right? If I said solve, you'd say, well, p needs to equal p sub 0 over t plus 1 raised to the c power. Or in other words, even like if you think about it when solving, which we'll learn next time, you could base 10 both sides, and then they undo each other. You guys kind of see? Okay. So now looking at this, it says, okay, so if your score on a history test is 90, what would you expect to get on a similar test after 2 months, given that c equals 0.2? So you go back and say, well, what does each variable stand for? In this one, it says performance level is p sub 0. So our performance level is 90 divided by, our t is time in months, so we have 2 plus 1 raised to the c, and they gave us c was 0.2. And you'll type it into your calculator, and you get roughly 72%. So if you were to take a test, apparently, and then take it without studying 2 months later, if you got a 90 the first time, you can expect to get around a 72 based on what this formula says. So that's without studying any additional time. You just have to read, plug into variables where it tells you to, if that makes sense. Good question. All right, awesome. So that is the end of the lesson. The rest of the time is yours to take very seriously working on homework.